Welcome to today's video that will cover a couple of concepts. First thing we're going to look at is how to sketch absolute value functions that involve quadratics. And secondly, we're going to examine something called piecewise functions and how they pertain to absolute value functions. So again, we are continuing our work here with the primary area of focus being on absolute value. So let's take a look at how I would sketch an absolute value quadratic function. So number one is we got to be able to recognize that we're dealing with a quadratic. And the way you tell that is that between these absolute value bars, you will see a degree 2 expression, meaning there's a squared in it. So that makes it quadratic. Well, we're going to make you dig back into Unit 1 and try and recall, how do I sketch just a regular quadratic? Ignore the absolute value. How do I just sketch any old regular quadratic? Well, we're going to use a strategy that involves finding the vertex. And for absolute value, you're also going to need to know the zeros. And zeros is the same thing as the x-intercepts. All right, so we'll get this information first, and then we'll consider the absolute value bars at the end and see how that kind of plays into things. Okay, let's start with the vertex. So you need to remember how to put a quadratic in vertex form. So we're going to take f of x equals, just ignore the bars for now, and we'll go x squared, take away 6x plus minus 16. Take half of this number, which would be 3, square it, that'll give me 9. So I've added 9 that wasn't there before, so I must take away 9 at the end. That way I'll get a net change of 0 on this side. X, so square root of the first, sine of the middle, square root of that one, all squared, subtract 25. So now I can see that this quadratic has its vertex at 3 and negative 25. Zeros is found by replacing y equals, or the left side here, with 0 equals x squared, take away 6x, take away 16. Now this may factor or it may not factor. This one will factor. If it didn't factor, we would go and draw upon the quadratic formula to solve this. So to factor this, we're going to go x subtract 8 multiplied by x plus 2, giving me the zeros at 8 and negative 2. All right, so we're going to put this all together now and see what I've got here so far. So I've got a quadratic that's going to have, I'm just going to extend this a little bit further. So I'm going to say negative 2 is there. I'm just doing a quick sketch here, so it doesn't have to be all scaled off perfectly. We're just going to get a rough idea. Let's suppose then that negative 25 I'll put way down here, which means right now this is what I found. I had these two zeros, and I had my vertex at 3, so let's say that's 8, negative 2, so 3 is somewhere right here. Say that's 3. And negative 25 is my vertex. So this quadratic, it's hard to draw this by hand, would look something like that. I'm out of practice. I haven't been using my drawing tablet much lately. Now it should be cutting through my zeros, but I missed a little bit, but you get the idea. Now I have to consider, what does this whole absolute value thing mean then? Well, from our prior work with absolute value, we should at this point know that when I take the absolute value, and on the right side there's nothing here except the absolute value of this expression. So once I fill some number in here for x, I'm going to get a number, I'm going to take the absolute value of it. Well, I think you hopefully would all agree that that is going to guarantee my answer is positive. Remember, f of x is interchangeable with y equals. So what this is telling me is that all of the y values on this graph, when I sketch it, need to turn out to be positive. Well, let's look at my graph. Did all the y values on this quadratic end up as positive numbers? No, they did not. Some of them did. These ones here, which are already positive, when you take the absolute value of positive numbers, nothing happens to them. So this part of the graph would stay exactly like it is. Same over here. These are already positive numbers. Nothing's going to happen to this part of the graph. It's going to stay the way it was. Right? So that stays the way it was. That stays the way it was. Now, here's where the issue is going to be. Down here, when I filled in my x value, here I got some negative y value, but I would then take the absolute value of that, and this would switch up and become the positive value. This would switch up and become the positive value. This would switch up and become the positive value. Now, what we do is we just use our vertex, which was at 3 and negative 25, and we just move it up to 3 and 25. So that would switch up to here, and by doing that, imagine like this was just a piece of string. So when I pulled the piece of string up, all these points would come with it, and they would switch up, and my graph would end up looking like this now. And this vertex here would end up at 325 instead of 3 negative 25. So the positive pieces of my graph stayed the way they were. When I say positive, I'm talking about the y values on this scale. The negative y values, so the piece down here, it just switched over and they all became the positive version. So that black graph would be the graph of absolute value x squared minus 6x minus 16. So in order for me to get that sketch, I needed to get the vertex and the zeros. Now, a lot of times we'll draw this first one. Students will say, okay, I get it. So these graphs are going to kind of look like the letter W. And I will say, yes, sometimes. Can you think of a situation where when you take the absolute value of a quadratic function, it's not going to take on the appearance of this W? Let's just scribble a couple of things down below this and see if we can drum up some ideas. So really when you sketch a quadratic, there's only 4 things that can happen. I could get a quadratic like I just had that did this. I could get a quadratic that opens down instead and has 2 x-intercepts. I could get a quadratic that opens up but has no x-intercepts. So it's like that. Or I could get a quadratic that opens down and has no x-intercepts. So it looks something like that. Well, think of these 4 situations. So this one we just did. So when I take the absolute value, this one, these would stay the same. These are negatives, so they'd have to loop up this way instead. So that's what would happen in that situation. This one's positive, so that piece of the graph would stay the way it is. These are negatives, they would reflect up, and it would look like a W as well. However, here, the y values are already all positive. So when you take the absolute value in this situation, nothing would change. It would look identical to the original function. So that one's not going to take on the appearance of a W. Now this one, all of my y values are negative. So when I take the absolute value of them, they're all going to switch and become the same y value except the positive version of it. So for example, this would go to here, 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 and this graph would end up looking like so. So neither of these two. So if the vertex is below and it opens down, or the vertex is above and it opens up, when you take the absolute value, you will not get that W shape to it. Okay, so let's have a look at a few of these and see how we make out sketch them. So I want to sketch this one. Again, this might be a spot where you might want to watch one more, but at some point you got to pause and try to do some of these on your own. So let's start with the vertex. Y is equal to x squared plus 4x plus minus 5. Take half of this number, half of 4 is 2, 2 squared is 4, so I've added that 4 that wasn't there before. Oops. So I'm going to take away a 4. Y would equal x plus 2 all squared. Take away 9. So this one has its vertex at negative 2 and negative 9. I didn't realize I had these linears. We already did linear, so we're good with those, we hope. So my vertex is at negative 2 and negative 9, and this quadratic opens up. So that tells me I should get, so that's below the x-axis, and it opens up. I should cross the x-axis twice then. So there should be some zeros. Let's find the zeros. What would make x squared plus 4x take away 5 equals 0? X plus 5, x subtract 1 if we factor it. So x could be negative 5 or x could be 1. Alright, here's what we found. We've got a quadratic, vertex at negative 2 and negative 9. It had zeros at negative 5 and positive 1. So this is what it looked like without considering the absolute value. Alright, again, don't make fun of my bad parabolas. It's hard to do these on this tablet. Alright, that's not my final product though. Now, anything that has negative y values, we are going to switch around. So this already has positive, that'll stay the way it is. This, they're all positives, they'll stay the way they are. However, this, 2, negative 9, will jump up here. Again, make it about the same distance. So that'll be positive 9. And this will be the point 2 and 9. And now my parabola will look. So there's my absolute value graph, the blue one. Right, so my final answer is the blue graph. Okay, let's have a look. So this one's a bit different in that I've got a stretch factor out front. Whoops, that's a negative, so it's opening down. Let's find the vertex. Now when there's a coefficient in front of x squared, you must factor it off. So take out your negative 1, which will switch your middle term to a plus 2x plus 15. Half of 2 is 1, 1 squared is 1. Now you gotta be careful when there's a coefficient out in front. That number gets multiplied by the coefficient. So really it's 1 times negative 1, which is negative 1. You need to put a number at the end to wipe that out. So you need to put a plus 1 there. Y will equal negative 1, square root of the first, sine of the middle, square root of this one, all squared, plus 16, vertex at negative 1 and 16. And it opens down. That's above the x-axis, it's opening down, it should have 2 x-intercepts in, so let's find those. Let's find the zeros. Take negative x squared, subtract 2x plus 15, make it equal to 0. I'm not a fan of having a negative in front of my x squared, so when it's an equation, I'll just multiply both sides by negative 1. And now I'm going to factor the simple trinomial, so it's x plus 5 multiplied by x subtract 3, giving me zeros at negative 5 and positive 3. Alright, let's put that all together. Where's our vertex? Negative 1 and 16. So I've got negative 1 and 16. Here's my vertex. I've got zeros at negative 5 and 3. So this quadratic, ignoring the absolute value, would look something like this. Now when I apply the absolute value, I'll do it in blue here, this piece of the quadratic would not change because the y values are already positive. However, these y values are negative, so I'm going to have to take the negative of them, which will turn them into the same numbers, but positive. And I think I have one more. So I just wanted to do one where the world isn't always perfect. Like the first 3 that I've done, they were all perfect numbers. Everything worked beautifully. Sometimes that's not the case. So let's have a look at this one. So nothing changes. Oops. We need to find the vertex. Now this one, when you go to find the vertex, there's a coefficient. It needs to get factored out. Doesn't go evenly. Well, nothing I can do about that. So we just write it as 9 over 2, x, plus 9. So we need to take half of 9 over 2, half of 9 over 2, that's 9 over 4. And then you have to square that. So that's going to make here 81 over 4. That number is going to get multiplied by your coefficient. So 2 times 81 over 4. Well, 2 goes into 4 twice and gives you 81 over 2. So this times this is a positive 81 over 2, which means at the end I need to subtract 81 over 2. So when I go to my vertex form, it's 2, square root of the first, sine of the middle, square root of this one. Now 9 over 1 would be 18 over 2, so a positive 18 over 2. And we take away 81 over 2. So that's going to give me 63. So a negative 63 over 2, which is negative, what, 31 and a half? All right, so the vertex is at positive 9 over 2, negative 63 over 2, and this quadratic opens up. So because my y value is negative, that means the vertex is below, so there should be 2 zeros. Let's see if we can find the zeros. So the zeros would be found by taking 2x squared minus 9x plus 9 and making it equal to 0. Hard trinomial this time, so 2 times 9 is 18. I need to multiply to get 18 and add to give a negative 9. So that would be 2x subtract 6, 2x subtract 3, negative 6 times negative 3, there's your positive 18, add those, you get negative 9. This one will divide by 2. This one's already good. So I get 2 zeros, they would be at 3 and positive 3 over 2. Okay, let's graph this. And again, you don't have to worry about scaling it off. Just draw an estimate of where you think things would be. So I've got, what do we got here? So 9 over 2, that's 4.5. So let's put 9 over 2 here, 4.5. Negative 63 over 2, let's put that down here. So there's my vertex. My zeros were at 3 over 2, which is 1.5, and 3. I don't know what the heck's going on here. X minus 6. Oh, the drawbacks of not having my audience live. So I did make a mistake up here, which I knew there was something wrong because I was getting my zeros, which were here and here, and my vertex should have been halfway between them, and it wasn't falling there. So something was wrong. So I paused the video, and after scouring through here, I finally see where my mistake is. It's up here. I didn't take half of this. So I should have taken half of 9 over 2 and said it was 9 over 4, which was right. I did it here. But when I squared this, I should have got 81 over 16, not 81 over 4. So that's going to change a few things here. So that's going to make this 81 over 16. So then when I multiply this by 2, so 2 times 81 over 16 is going to be 81 over 8. So this should now be 81 over 8. And that will make this 81 over 8. So now that's going to change, that's going to change this number. So 9 over 1, if I put it over 8, is going to be 72 over 8. Over 8 minus 81 over 8, why is that doing that, is negative 9 over 8. So negative 9/8. This will now be 9 over 4, because you'll do square root of the first, sine of the middle, square root of this one should be 9 over 4. That'll change my vertex to 9 over 4, and this will be minus 9/8. Okay, let me fix this. So 9 over 4 and negative 9/8. So that will come down here now and fix this up. See if it makes more sense now. Okay, so now let's start with what we got. So we had our zeros at 3 and 3 over 2, which is 1.5. So let's say that's there. 9 over 4 is 2 1/4. That makes more sense. Now that's in between these. And now my vertex wasn't down very far. It was only at negative 9/8. So let's say that's here. Like that eraser on there. So negative 9/8. So my quadratic, without applying absolute value, would look like this. But switching to absolute value, well, this will stay the way it is. This will stay the way it is. Arrows. This loop here will turn and come back up this way. All right, so that is how you sketch absolute value quadratic functions. So I think I'll stop that video and let you kind of work on that concept, and then I'll make a separate video that will deal with the piecewise, just so that they're not all clumped together in one big long video. All right, so thanks for watching this one. Once you feel comfortable with this one, then you can watch your information or your video on piecewise functions. Thank you.